26. A sample of air has a volume of 140 mils at 67 degrees Celsius. Well, we're using Charles' law. I don't want that in degrees Celsius, so 67 plus 273, that's 340 K. Okay. So we have V1, we got ourselves T1 at what temperature? What temperature? So that means that we're going to be solving for T2. Well, its volume be 50 mils at constant pressure, right? That constant pressure is just letting you know that it is in fact okay to use Charles' law. Charles' law's pressure, Charles' pressure, Charles' pressure. So we need to solve the equation V1 over T1 is equal to V2 over T2. We need to solve that for T2. So I'm going to get T2 onto the numerator by multiplying both sides by T2. That cancels T2 on the right side, but it does get it as a numerator on the left side. So I have T2 times V1 over T1 is equal to V2, and I'm going to have to multiply both sides of the equation by what's going to be a fraction. I multiply T1 so that they'll cancel there. I'm going to end up dividing by V1 so that that cancels there. And so over here, I have to, again, multiply and divide by the same thing. And so I end up with T2 is equal to V2 T1 over V1. So we can write that down nice and cleaned up over here. T2 V2 T1 V1. Alright, now we should have all the numbers that we need. Okay, so sum for T1, okay, so V2 right there, that's V2 50 mils. T1 340 K divided by V1 140 mils. This, by the way, this has 4 significant figures, but this bad boy has 3 and 3, so I'll probably end up going with 3. Milliliters cancels milliliters. My only number here left is, or sorry, my only unit left here is kelvins. So let's plug and chug. 50 times 340 divided by 140, and I end up with 121K. If you wanted to report this in degrees Celsius, you can totally do that. You just subtract 273, and you end up with negative 150, I guess negative 152 degrees Celsius. Right? It's a very, very cold temperature. Very, very cold temperature.